Welcome back to our masterclass in strategic thinking, dear friends. In our previous video, we explored how to recalibrate our inner world to develop a strategic mindset, committing to self-mastery, opportunity detection, and influence as dimensions in our ML model. In ML, a dimension is simply an attribute that characterizes data. Our work on self-mastery challenged us to audit strengths and vulnerabilities as our main ammunition. That exercise produced labeled data, placing us in the realm of supervised learning. But life doesn't always present itself so neatly. Goals and resources often unfold amid unlabeled data, pushing us into unsupervised learning. How to spot an opportunity, data selection in unsupervised learning. From Sun Tzu to Nassim Taleb, all masters we've cited agree. A strategic mindset rests on adaptability and openness to change. Seizing opportunities demands focus on the essential, readiness to cut losses, and constant recalibration. Even with unlabeled data, we must reduce noise, explore feature importance, and analyze patterns. The strategist constantly asks, where does this route take me? Is there a more efficient way to operate? What risks are involved? Here enters Principal Component Analysis, PCA, a tool for distilling essentials and discarding distractions. Unsupervised learning, clustering and association. Unsupervised learning offers two main approaches, clustering and association. Clustering groups similar data points. In life, large clusters, professionals in your industry. Smaller clusters, facilitators, gatekeepers, investors, or top players. K-means clustering assigns each cluster a centroid and minimizes distances around it, ensuring cohesion. To choose the right number of clusters, the elbow method identifies the point of diminishing returns. Just like in networking, beyond a certain number of events or memberships, opportunities converge. Cluster evaluation tools remind us to check accuracy, distortion, similarity, inertia, and separation, done index. The second family of algorithms in unsupervised learning is associations, which lead to the if-then relationships. If I get a VIP ticket to a top conference, I can interact with decision makers in the executive lounge. Algorithms like a priori use support, how often something occurs, confidence, how often A leads to B, lift, how much more likely A and B are to occur together than separately, returning to supervised learning, filtering opportunities. Once we've surveyed trends, mapped hubs, and identified gatekeepers, we can label our data again and return to supervised learning. But as Sun Tzu counsels, only fight on favorable ground. An opportunity qualifies if it is feasible, aligned with our current work, uses available resources, and carries manageable risk. We can refine analysis with correlation, identifying interconnections, mutual information, measuring impact between features. Algorithm selection opportunities can be analyzed with classification, initial filtering, and regression predicting outcomes. Using synthetic datasets like make classification or make regression, we define parameters. N samples covers various scenarios which may accommodate opportunities. N features gathers all objectives that can raise our interest and the factors which can affect it. N informative focuses on our top priorities, such as attaining brand awareness for a recently launched project. Noise includes any irrelevant influences. Random state tests the extent to which tactics can be applied on more circumstances. Opportunities can be addressed through the following algorithms. Support vector machines, SVMS, establishes boundaries as classes are recognized, reflecting Sun Tzu's advice to always know our ground and use it to conceal your movements. Polynomial regression highlights continuously growing stakes, risk, and pressure, leading us to Robert Greene's observation over how the moment of victory is often the moment of peril for those who seize opportunities but don't know when to stop. K nearest neighbors, KNN, classifies by similarity, reflecting Sun Tzu's strategies on appearance interplays, such as making one's enemy uneasy when they are at peace, tiring them when they are rested, or sowing division when they are united. Decision trees dissects possible outcomes for every decision we consider, preventing us from stepping into fallacy costs and getting us closer to Sun Tzu's warning over how we should pick battles that we can win and avoid those we cannot. Random forests facilitate multiple perspectives for evaluating an opportunity, revealing those paths our enemy does not expect, as we're taught by Sun Tzu. Neural networks mimics the brain, best to anticipate Robert Greene's advice on acquiring the long preparation for meeting the moment of opportunity. Generative Adversarial Networks, GAN, allows us to create our own opportunities, leading us to Peter Thiel's inspirational advice on pioneering. The next Bill Gates will not start an operating system. The next Larry Page won't start a search engine. The next Mark Zuckerberg won't start a social network. If you are copying these people, you are not learning from them. Training and testing. With train test split, we learn from past experiences training and apply lessons to new ones testing. Recursive feature elimination, RFE, prevents fallacy costs, wasting resources on irrelevant factors. Model.fit equals learning from experience. Model.predict equals projecting into future scenarios. We can then evaluate results through permutation feature importance, return on investment across tangible and intangible gains, R squared, accuracy of our assumptions, MSE, size of overlooked risks, MAE, tolerance for deviation, classification reports, precision in opportunity analysis, and recall for estimating its life cycle or unfolding, K-fold cross-validation, consistency across objectives, fine-tuning. We might rely on the results we obtained, but a double check is never a bad idea. After all, as Stephen Hawking famously said, the greatest enemy of knowledge is not ignorance, it is the illusion of knowledge. Fine-tuning calibrates the learning rate and the epoch. Think of the learning rate as how much knowledge we integrate before deciding. As a full rotation around the dataset, the epoch can reflect how many experiences it takes to refine intuition. What about the training data we worked with? Machine learning models are often challenged by Gini impurity, which identifies mislabeled events, and entropy, which measures the level of disorder or uncertainty within the dataset. Gini impurity resemble hypes that lead nowhere. As for entropy, think of chasing shortcuts without structure. Opting for regression models exposes us to bias, oversimplification, and variance, hyperadaptability. Bias creates underfitting models which are too rigid, fatal for a strategic mindset, which, from Sun Tzu to Robert Greene, should adapt to change. Variance leads to overfitting models which become too reactive, just like our thoughts when we lose focus. After all, as Sun Tzu teaches us, the supreme art of war is to subdue the enemy without fighting. We can maintain both our bias and our variance low through regularization, which can be attained the lasso and ridge methods. The lasso focuses on the most important traits, ideal for opportunities designed to deliver results in a short time frame. The ridge method balances everything, even if imperfect, recommended for long-term brand building. Ensemble learning, combining the strength of multiple algorithms. How many disruptors created completely new business paradigms by eliminating any conventional understandings of feasibility, using other people's money, or empowering other stakeholders along the way? Whenever we want to pioneer by getting the best of any known path, we have the three ensemble learning methods combing models. Bagging trains, models independently, combine results through voting for classification or averaging for regression. Think of applying Robert Greene's advices on interplaying appearances when we want to get in the right rooms and at the right tables by average timing, strategic withdrawal, humbleness, or the perception of confidence. Boosting implies training models one after the other, fixing the errors produced by the previous ones. A combination of all models creates prediction. We are being reminded to create our own opportunities. Let's therefore think of boosting as keeping an overall vision to which we manage the tactical details, as Robert Greene suggests. Stacking implies training different models and using their predictions as inputs for a final model, just like Robert Greene's advice on winning loyalty through small victories. Opportunities are never static. Our vision is constantly readjusted to new resources, facilitators, or detours. In machine learning, the model.transform function allows us to adapt to any new development. But never forget, Strategic adaptability depends on constantly revisiting mutual information, understanding what features reveal about one another. Above all, clarity is the prize. In ML, permutation importance asks whether performance collapses when features are shuffled. In life, the question is the same. Can we keep our eyes fixed on what truly matters? Opportunity detection, like ML, is an iterative cycle. We cluster, associate, label, filter, test, prune, and recalibrate. We balance bold moves with patience, foresight with flexibility.